Hi everyone, my name is Sergey Koshelev and I work as a sales engineer at an ML company called Tulaka. Today we're going to talk about solving a problem of measuring search relevance using crowdsourcing. And first of all, let's start with definitions. Search relevance is the measure of how the search results relate to the query. So when you type in a search query, you get a result page and you want to know about each result, whether it's good or bad for the given query. So we can use this measure in assessment of search engine quality to know whether our search engine is robust. Then when we get the labels for each query and result pair, we can use it to train our search algorithm and thus improve search engine in general. And crowdsourcing is the approach we are going to use. And it basically implies solving a large problem by dividing it into micro tasks and outsourcing it to external annotators. So these annotators are not going to be the experts in the given task because you are the ultimate expert in it. But your goal is to divide this problem in such simple tasks that can be solved by just using common sense and guidelines you provide to your annotators. And why do you want to use this approach? Is because the search algorithm is an ML model, and the model needs to be trained on pre-labeled data. So we want to have correct answers for the input that will be given to this model. And crowdsourcing approach is very fast and scalable and adjustable because when you use it, you tap into a large pool of potential annotators. They can work on your tasks pretty fast because there are a lot of them. This approach is scalable because when you try to annotate data yourself or using some in-house experts, you can't label it fast when you have large volumes, and you will require large volumes for training a search algorithm. And usually crowdsourcing is a highly adjustable approach because different crowdsourcing platforms provide a large variety of different settings and pipelines. And now when we defined our problem at hand and our approach, let's just crowdsource search relevance. And this will boil down to asking the annotators to assess the relevance of a search result to the search query. So how will we do that? First of all, we need to collect a data set of query product pairs. Then we need to choose an evaluation scale, the categories, which will be used to label these pairs. Then we will need to describe it in the guidelines for the annotators, set up a crowdsourcing project, which consists of an interface for the annotators and settings to filter and train our performers, because they are humans and we will need to describe the task in hand and choose a relevant subset from a large crowd of potential annotators. And when these annotators start working on our project, we will need to control the quality of their answers. So the hardest and the most important part is choosing an evaluation scale and describing it in the instructions. So we need to define the relations between the result and the query with a consistent, unambiguous set of categories. So imagine that you have a query like pink iPhone, and you get a result that shows you a green iPhone. You need to describe this relation or the result of the query via some category. And it can be a simple binary scale or just relevant or irrelevant. This scale is good because it's simple for you to analyze, but it can be quite hard for the annotators to use because it's very broad, it's very vague. So you can add more categories, like using a trinary scale of relevant, somewhat relevant, or irrelevant. But again, it's kind of vague. So if we transition from just web search relevance to product relevance, you can use a specific scale design for this type of tasks by introducing something like exact match relation, substitute product, like, for example, providing a Samsung phone for a user who's searching for an iPhone smartphone, or this relation can be described as an accessory product, like an iPhone case for the iPhone query, or just an irrelevant result. And the clearer the differentiation between the categories, the better, because again, they should be very consistent and unambiguous to have high quality results. And naturally, you will have to explain all the categories in the instructions, give examples of such labeling, and describe some tricky corner cases. So again, the industry standard for web search relevance is describing it in terms of being relevant or irrelevant. But when you are dealing with product relevance, it's better to introduce an unambiguous category scale like exact match, substitute product, accessory, or irrelevant. And when you've decided on the set of categories and the instructions, you will have to set up a task interface. And there are several approaches here. For example, using screenshots or using links to the products. So the pros of the screenshot approach is that it reduces the amount of redirects from your task, because it will be way faster if all the information needed for annotation is contained in your task interface. And the screenshots don't duplicate, which means that when you have a dynamic page, when several days pass from when you form the task, the data in the page can change, which will result in noisy output. But on the other hand, when you are dealing with just links, it takes less efforts to prepare the task, and the link can provide full information on the product. But you can always combine this approach into such an interface that contains all the information about the product in the task itself, but it also has a link to the product on your website. And now, when you've created an interface, let's quickly go through the whole labeling pipeline. This pipeline starts with tapping into a huge crowd of potential annotators, and then you need to filter a relevant subset of them by using some maybe geographical or demographical filters or language filters, because, for example, if all your results are in English, actually you want to use only the annotators who speak English. Then, when you've chosen this potential subset of annotators, you provide them with your instructions. And after they read the instructions, they go to training, which is usually a small set of tasks with known correct pre-labeled answers and explanations, so that when an annotator makes a mistake, he or she is shown a hint describing how the labeling should have been done. And then they go to the examination part, when they are not shown the explanations, but their answers are measured, and only the ones with the highest quality, highest accuracy of answers get access to your main data set. And when they are working on your main data set, you want to still control their quality by mixing in some control tasks with known answers, so that the annotator doesn't know whether the task at hand is a control one or just a regular one, but you keep measuring the metrics of their quality. And when you're doing a large-scale labeling, you can't maintain and in more controlled tasks by yourself or by in-house experts. But you can always reuse the answers from the previous annotators, the answers you are most confident in, to mix them into the tasks for the newcomers. And in the end, to get a result data set that consists of a search query, the search result, and the label that describes the relation. So now you can analyze these results, and good news is you can use all your industry standard metrics for that, like Matthews correlation coefficient, precision recall, F1 for all the classes, as well as micro, macro, weighted or whatnot, average for each metric. And then when you see that your labeling results are good, you can measure your search relevance, and the industry standard here is NDCG, and thus you can learn whether your search engine is good or not, and train a model to make this engine even better. So thank you everyone for your attention. And if you're interested in trying such a pipeline yourselves, you can always go to Toloka website, register as a requester, use the promo code you can see right now, and start your labeling. Thank you.